Hi everyone, how is everyone doing? This is the second time I'm trying to connect. We are facing some technical issues. I'm actually not sure what's wrong. There might be some problems with the chat as well, so don't be alarmed if your messages won't display. I see the chat, so sometimes I might just read aloud what you write, so don't worry about this. I see Tim is here. Yes, you had the wrong link, possibly because there is just so many links and not all channels are online right now, as I can see. But nevertheless, let's just continue and let's do it. Let me just close the browser windows to save some CPU. And yeah, let's do some quantum programming, guys. Welcome to the third episode of quantum programming. I'm Marek Narozniak, and today I'm going to talk about quantum measurements. Hopefully everything is going to be fine, everything is going to be recorded, unlike last time, unfortunately. Let me just do a little advertisement first. So take a look at this very cool graphic. So that's a new video from Tim's channel, Quantum Technology Lab, about warping space-time. If you're the space-time kind of person, you might like it a lot. And if you're not, you might still like it a lot. Another good news is that the beer is back. We can have a drink together. So make sure you prepare your nice cold drink at home and sit comfortably, ready for the stream. So this video is about, oh wait, the wrong chat is being rendered. Oh yeah, hi Manish. Hi, hello. We can see the messages, great. So yeah, so the video is about how quantum effects can affect space-time curvature changes over very small. You're welcome. Always happy to advertise your videos because they're just good and funny, and I'm there, so I'm also promoting myself. So as I was saying, you can actually, but this video actually I'm particularly happy to advertise because it has some relevance for the stream. So just briefly, there are some small frequency changes that could depend on the spacetime curvature, and I have not yet introduced Schrödinger equation. Yeah, thanks. I have not yet introduced the Schrödinger equation on this channel, and I realized that the problem presented in this video is actually perfect. So we might actually do it at some point. But for now, just, open YouTube and find it. I will also post the link in the description and you can check it up. So as for today, first of all, priorities. Cheers, guys. Good health. Hope your drinks are ready as well. Yeah. Okay. So today we are going to talk about measurements. So I prepared some challenges for today. So first, we are going to implement a little measurement function. We are going to talk a bit about measurements and then simulate them. And then I have few challenges about coins. So without further ado, let's talk about quantum measurements. So the challenge I prepared is implement a Python function such that given a quantum state, number of qubits n and number of samples m, would perform m measurements in the z basis and return the count of how many times each of the outcomes has been measured. So this is basically, cheers Manish. So this is basically something as you can have in IBM Qiskit. Sorry, that's a blasphemy of me to confuse the two. So the reason why it's relevant is there's actually something interesting going on when it comes to quantum measurements. So actually, you can, from the first episode when we talked about quantum states, you might have noticed that quantum states, episode 003.py, quantum states can store exponential amount of information in linear amount of qubits. And in the episode 2, you might have seen that quantum states can have exponential amount of information processed with linear amount of operators. So this is a very interesting thing that drags attention to quantum systems as, you know, potential means of building computers, because, you know, you can do exponentially more than you actually have. So everyone would like to have that. Of course, there are limitations because you can only solve problems that are, you know, solvable using Schrödinger equation. So it's not as good as it seems. However, that's a very interesting property. And measurements are relevant here because this way you can see that you cannot actually extract this exponential amount of information. You hold exponential amount of information, but like, let's say, all the possible outcomes at the same time, but when you measure, you only get one outcome. So that's the limitation, and that's what we are going to simulate today. And basically everyone who works with the quantum systems knows about it, but nobody knows why it happens this way. And this is why there are so many interpretations of quantum mechanics, because nobody knows why it happens like this, why the wave function collapses and chooses just one outcome. So there are those many ideas. Like, the most widely known is the Copenhagen interpretation, but there is many worlds interpretation as well, where, you know, every time you measure you get one outcome, and there's another universe in which there was another outcome, etc., etc. So just to facilitate today's stream, I prepared a little code just to save us some time. I prepared a plotting function that makes histogram. This. And you can also see the prepare measurement, which I forgot to remove. Okay, let's pretend that this was never here, and pretend you have never seen that. Busted. But it's okay, guys. Actually, this solution has been written by me long time ago on Stack Overflow. Here's one that I prepared earlier. Yeah, that's true, but to my defense, actually, someone asked a question on Stack Overflow, how to do quantum measurements, and I replied with a solution, and that's the solution. So I did it years ago, actually. I answered to someone, and this solution got some upvotes. So it's not something I prepared for the stream, you know. I had it long time ago, and now I'm just going to redo it for you guys. So just pretend you have not seen it, and yeah. Let's do it. So we are going to, hold on, let me just pull that thing back again. That's not my fault, it's the Emacs. I'm actually not so experienced with Emacs. It still keeps doing things that, you know, I don't really know exactly how to do it. So, well, as usual, we need Qtip, because we use Qtip for everything. Wait, from Qtip, import basis, because we will make states. And And yeah, so this is going to be prepare measurements. It will take how many qubits and a quantum state psi. Speaking of, there is new video in production on NYU Quantum Technology Labs about quantum supremacy, and I highly encourage to use the word supremacy. So we would make you know, all the possible outcomes, right, for the n qubits, for n qubits. And oh, actually there's even bigger failure than this, because I was going to generate quantum circuits for you guys, but the library that generates them did not work, so I just had to draw them on my iPad. It's going to be super ugly. That's okay, it's fine. It's fine, it's weekend. Let's not worry about stupid things. Yeah. Yes, working on it now. Good. And it is very un-PC to me. I'm a Unix guy, you know it. Quantum supremacy. That's politically incorrect to say, Manish. Watch your tongue. You might not get a job in academia in the future if you keep saying such offensive things. So, from the quantum state, we will have to extract the probability distribution, and for each of the configurations, and we will return both configurations and the distribution. So eventually it will be something like this. So the configurations, probability distribution will be something like P, and we will just return configurations and P. As for the configurations, we will use our favorite library called itertools. Let's just import it. I have a feeling that today's stream will be so long. Actually, I just woke up, guys. I fallen asleep and I just couldn't wake up. That's why I'm so disorganized. What was it? Itertools. Itertools, yeah. This semester is really killing me. Okay, itertools, product of 0, 1, 0, 1, yeah, 0, 1. Repeat n times. It's going to be wrong anyway, but let's just do it. So for each of those configurations, oh, I missed your message. Auto-correcting me, yeah. Crazy stuff, guys. So for each of the configurations, let's not confuse names here. I was also going to change some fonts and improve the way it looks. Didn't happen. Just say didn't happen. So we will need to like project the state. So you know, we will just take overlap like this. So outcome psi to extract the complex coefficient. So the outcome state can be built from the configuration. So let's make it like this. And we use the basis. 2 levels, not 21, just 2 is enough. For M in configuration. So basically it will make, you know, it will just make cat out of it. So conf is the list, and psiref is going to be cat that has, you know, spin configuration as the list indicates. And we need the probability of such outcome. probability of measuring this outcome. And for that, we use the fidelity as done in episode 2.5, sorry. Absolute value squared, our favorite thing, makes us not worry about the face. This is going to be squared. I'm so sleepy, guys. I feel I'm going to fall asleep. And we take the overlap. I'm not looking forward for Monday. So Tim, have you already seen Dune? Tim is going to see Dune this week. Put P in the distribution. Drunk programming. Drunk programming is the best. The best and the worst code I have ever written was always drunk. Large P takes little p, and we make a numpy array out of it. So we are basically simulating, this is like a virtual guy in a lab that just grabs, just performs experiments so many times, and every single measurement gets just writes down in the lab notebook. That's what we're doing here. So from this distribution, we are going to sort of make outcome counts. So let's make a function called simulate measurements that will just grab the all the possible configurations, probability distribution, and how many measurements you want, and we will just make a random choice of range, because it should go from 1 to 2 to the power of 10. Oh, you will see it this weekend sometime, yeah. Hot water, come on, man. Don't be so cruel. Yeah, so Tim, once you see Dune, please send me a message and tell me what you think about it, because I'm just so in love with this movie. So brilliant. So, guys, do you prefer 2 to the power of n, or no, not little n, should be large n. So that's hidden in the conf. So the length of configuration, because there's 2 to the power of n configurations. We want n such measurements, and the probability distribution is big P. Hot water is good. Come on. No. So yeah, how about we try it out? Let's make some state. Psi tensor basis to 0 basis to 0, and we can okay, so number of qubits here is 2, right? Let's say we want to make how many measurements do you guys want? 5. Let's make 5 measurements of this wonderful state. So the way you use this thingy is you first get this all the possible configurations and the probability distribution, and we use prepare. Yeah, go nuts with the exponentials. Well, I'm doing a lot of computational complexity now, and I spend a lot of time staring at the powers of powers of powers of something. But let's not talk about classes, because that's toxic and unhealthy, at least for me. I don't know, maybe your students are watching it as well, who knows, anyone could watch it. Let's see how much you can push OBS. Well, you know, it literally crashed just now. This is the second time I run the stream today. So, yeah, it's quite random. Okay, and we make the measurements from it using the simulate measurements. We give it the configurations, probability distribution, and number of samples. And yeah, so that will sort of contain all the counts. This will be like, oh, I measured the state number 5, I measured the state number 10, then I measured the state number 10 again. So we would probably want to have like a unique list of what has been measured and the counts of them. So let's use NumPy for this, like that. NumPy is so great, guys. You can do amazing things with it. Yep. And let's use our histogram thingy. How did I name it? Let me take a look again. Gosh, I'm so sleepy. Histogram. Wow, that's a surprisingly user-friendly. From plotting, import histogram. And yeah, histogram, unique counts, number of qubits, number of samples, title, test, and let's call it, how do you want to call it? File name result.png. That should do. So let's wait, Emacs, listen to me. Tim, you used to use Emacs, right? And you hated it. Let's open a shell. Doing the student times. Bash profile, just so that we have the right Python version. Python v, let's just double check that. Yes, that's good. Where we are in the right place. Episode 003.py. Tensor is not defined. Okay, there you go. I will give you your tensor over here. See guys, I'm not doing copy paste. It's not copy paste at all. I didn't have much other choice. I was using Unix. Oh, for you. Prepare measurement is not defined because I forgot an S somewhere probably. Prepare measurements, and here I call prepare measurement. Oh, actually the choice for serious users was Vi. Vi is okay, but I don't know. I mean, Emacs seems just more badass, so I don't know, maybe I'm masochistic this way. Alright, I have to copy paste because I'm too sleepy. Emacs was for the week. Ah, come on. Don't say that. Emacs is beautiful. NP is not defined. Right. Okay. Okay. There you go. Import NumPy as NP. Really? At the times Vi was considered badass and Emacs for the week. Well, I don't know. I mean, the learning curve of Emacs is just crazy. It's like a random function. And Vi, you know, once you know how to use the colon, you sort of figure it out. Game of Emacs and Unix. Well, yeah. Arrow. Okay, it's array, not arrow. A wild arrow appears. I should play some Pokemon on the stream. So many things to do. A and P must be same size. Right, one more time we end up in quantum debugging live stream kind of scenario. The problem appears to be here. For in configuration, repeat n times. That seems totally fine to me. There is some size mismatch somewhere. I think it is between line. Hold on, let me enable the line numbers. Line 25 here. Okay, so the distribution is not the same size as the configuration, but why? Did I give it the right distribution? Now I regret I did not copy paste. This is going to be a long live stream, guys. Maybe the N is wrong. P is P. Well, I use Word in Windows now, so whatever. Did you know that people write in DOS, actually? You can totally write books in DOS. Dune's scenario was written in DOS. What's wrong here? A and P must be the same size. They are. They are the same size. There is 2 to the power of n outcomes. There is 2 to the power of n outcomes here. And we have a probability for every outcome that goes into P. So P should be 2 to the power of n. Hold on, let's just check. Let's just check, guys. Quantum debugging live stream. Two and 4. Okay, yeah, it's wrong. Why it's wrong? N is 2, that's right. Let's print the configurations. This is going to be a really long episode. I'm already the target time to 30 minutes and I haven't even done any challenge. Okay. Okay, whatever. It's a debugging exercise, right, Tim? Wait, forgot the S here. We can make episode 2 tomorrow or Monday instead of Final Fantasy livestream. It's fine, it's 4, it has 4 elements. Haha, that's right, yeah. Debugging exercises are the best. I'm glad I have this thing. I might pause the stream and go grab another one. You guys have any beer there? Poop. Come on. Oh, I know why. Because I returned the last configuration instead of all the configurations. I just forgot the stupid S. Now it should work. We done it. Guys, we have it. We know the problem. Human error. I am the source of errors in this code. Okay, okay, measurements not defined. That's just another S over here. Oh yeah, fuck yeah. Okay, let's see. Let's see. Yep, 5 measurements. 0, 0 has been measured 5 times. Good. We have it. We have it, guys. We have it, guys. We are back on track. Thanks. So anyway, what are you guys drinking there? I have Guinness. Irish stuff. Oh wow, yeah, yeah. Yeah, you know, I don't know, I mean, you get happy with the more and more stupid things with time as you get older. I suppose in like 10 or 14 years. Hot water always, come on, like, this is, we all know it's not true. What are you sipping there, Tim? What do you have there? You must have something. Just copy those first 3 challenges for now. The coin challenges. Control C. Green tea as well, yeah, right. Come on, guys. Everyone knows you're lying. Just tell the truth. What are you drinking there? What do you have? Green tea. I had green tea last night, but I had sushi for dinner. My Friday nights are basically sushi and movie, you know. New way of spending time. Okay, let's do some coins. Funny thing, I prepared some coins to like throw around and play, but I forgot them. So no coins. You have to use your imagination. Gosh, I'm so drunk. This. How many percent does it have? Anyone? How many percent does Guinness have? Smooth and creamy. Okay, I know that. Gosh, this is strong. I had cup of tea. You're kidding, right? All right, I'm getting distracted again. What? 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 Yeah, what? Exactly what? Coins challenge number 1. 2 coins are placed heads on the table. Nothing happens. Program a quantum simulation of that scenario, provide a quantum circuit and histogram of counts of measurement outcomes. Oh my god, this could get hilarious. Of course, of course, of course, it's going to be hilarious. And imagine if I grab another one, that's going to be even better. So basically, we now we kind of simulate like a scenario when nothing happens. So let's just map some states. So heads and tails. Heads, it's going to be basis 2 level because there's heads and tails, and 0. And wait, tails. What's wrong with me? Tails is basis 2, 1. I think that's fine. So we just place them on the table. 2 of them are heads, nothing happened, and then we measure. So number of samples is number of time we throw them in the air. Is this how you say in English, to throw a coin or toss a coin? Whatever. And then we measure, you know. So our psi is heads, heads. And then we just do this thingy because nothing happens, right? And let's just remove that thing because it's going to pollute our data. Okay. Yep. So we have 2 coins. Both are placed on the tables. We do not throw them. 5 times we do not throw them, and 5 times they're heads. Sounds good to me. That's what I would expect. So let's pass to the second challenge. Let's get this live stream going before I run out of fuel. Yeah, either one, but tails sounds French. Merde. Oh, yeah. So is there an alternative word for tails in English? In Australian, sorry. Because in Polish we say eagle. Elbow cow. Sorry, did not render, but I know it's a cow emoji. So everyone, let's just use your imagination and pretend it's a cow. So the next challenge is 2 coins are placed heads on the table. We flip the first coin, program a quantum simulation of that scenario, provide quantum circuit and histogram of counts of measurement outcomes. So here I say flip. I do not say toss or throw, just flip. So they are both placed heads, and one of them gets flipped, okay? So how to do that? Probably we will need some operators for this. And, well, we still start with heads, right? That thingy. And now we will need to do something to the state to flip the second coin. And if you recall the bold sphere, we would need something that turns bold guy into a ninja, probably. So either X operator, either Y operator, whatever, both work. So let's make some X's. Make some X's. Sigma X. Let's make X1. Sigma X. Identity. Seriously, guys, this live stream becomes, I don't know what it becomes, but I sort of like the direction it goes. I'm wondering if those people from, big companies are watching it, and if they're going to offer me a job or something. I think not. So X2, because we flip second one or the first one. 2 coins are placed, nothing happens, program coin, that's the first one, sorry. Flip the first coin. Okay, we flip the first coin. So psi f x1 times psi 0. So that will turn heads into tails, or in other words, will turn bald guy into a ninja. And the rest should be exactly the same. That's here. Except that now we do it on the final state, so psi f. This deprecation warning is really pissing me off, so let's just take a short break and disable the warnings. Disabling the warnings is just so naughty. I hate warnings. Well, filter, warnings, ignore, category, deprecation, warning. I'm too drunk to write such long word correctly. Okay, hopefully now no more warnings. And also let's just... Oh wait, this is the TK warning. Okay, so we have to set an environmental variable for this. Export TK silence. How about you, Manish? Have you seen Dune? Deprecation 1. Okay. Now we can just running without any annoying output. Let me pull up a chat. illegal activities are occurring right now. It's purely academic. Well, I'm home. I'm home. I'm allowed to drink here. Warning is not defined. What? Come on, it's warnings. This day I just forget to write S everywhere. God damn it. Deprecation warning. Warning. Guys, don't drink and code. Don't. If you drink and code, just copy paste. No, the suppression of warning is illegal. Yeah, you have to take it. You have to listen. Q. What's that? It's QI. It's QI. Which line? Which line? Line 40. Here. Identity. Yeah, you have to take the warnings on your chest. You have to listen to it. I watched Bollywood songs and movies. Well, okay. So, what do you recommend from Bollywood, Manish? I will honestly give it a chance. I mean, maybe it will be like 5 hours long and a lot of dancing, but I can do it. Sure, we'll find to watch during holiday sessions. Good. I really recommend it. Guys, we have our result. Our result is up. So we put both coins heads and we flip the first one tails. So, and we do it 5 times, and 5 times we measure tails heads. That sounds like something we would expect to happen. So let's pass to challenge 3. 2 coins are placed heads on the table. We throw the second coin. Program a quantum simulation, blah, 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 blah. Okay, so now we will throw the second coin. So for that, we would need something that is ambiguous between heads and tails. And if you recall the bolt sphere, that would be like any guy with hair who is not a ninja and who is not bald. So we need to find a way to create hair. So we need a Hadamard gate. Guys, I'm totally cheating. I'm looking at my notes. I don't even care anymore. S0. S0 is the sacred Hadamard. S0 n because there's n qubits, and target is 0 because counting starts at 0 whether you like it or not. And n target is 1. If this video doesn't get popular, then I don't know what will. And yeah, so otherwise we do the same thing. We start by placing our coins heads. And we don't flip. We just throw the second coin. So H2. Was it second one? Let me just read again. Yeah, throw the second one. Yeah, so we apply the Hadamard gate on the second qubit just to create an ambiguous state that is ambiguous in the 0-1 basis. And we perform exactly the same measurement as before. Guys, you must feel so bored now. Let's run it. Let's just run it. I want to see Manish break out of Bollywood dancing. Oh, we have someone. Want to become famous. Buy followers. Don't read it out loud. I'm not falling for that for the second time. Oh my god, I want a team to dance Bollywood songs again. Okay, we have our result. Our result is up. So sometimes 0-0 was measured, sometimes 0-1. So we throw the coins 5 times, 4 times. Sorry, we throw the second coin. The first coin is just always heads because we don't throw it, it just lays on the table. Second coin we throw 5 times, and 4 times it got heads and once it got tails. So let's just increase the number of throws from 5 to something more like 50, or I don't know how many you want, 200 maybe. And let's see how it looks. Whoa, spam. Yeah, I get those spammers writing here all the time. I mean, all the time. Second time. Uh, yeah, that looks. Yeah, so it's about half-half. So let's be serious again. Focus to coding. Yeah, yeah. I'm getting distracted. This beer is strong. Okay, so the at the limit of infinite number of coin tosses, the distribution would become exact half-half. But in the finite number of throws, it's not guaranteed. So the more we increase this number, the closer it would be to, like, half-half. So let's make 2,000 of them, and that should look even closer. We can do it, guys. 46 minutes. Bear with me, almost there. Yep, looks like half-half. Good. Okay, we have 3 challenges done. I think there's 2 more left. Let's do them. Challenge 4 and 5. This episode is just, I think it's going to be my favorite so far. I should drink Guinness from now on during the streams. Whoa, 50-50, yeah, 50-50. That's the most fair distribution. Okay, coins challenge 4. 2 coins are placed heads on the table. We throw the first coin, and if it lands tails, we also throw the second coin. Program a quantum simulation of that scenario. Provide quantum circuit and histogram. Okay. Okay, guys, let's do it. Just copy, paste, because that's how it starts. So for sure we throw the first one, right? So we do Hadamard 1. And now it's interesting. Now, if the first one lands tails, right? Yeah, then we throw the second one. So we need some sort of controlled Hadamard gate, such that it gets applied only in the subspace of first qubit being tails. Let's call it CH2. And let's implement such operator here. So for that, we would probably need some projectors. I just look at my cheat sheet, I'm not even hiding it. So for the first qubit, we will need to project the subspace of 0 and subspace of 1. So P0 is a subspace of 0 of the first qubit. So the first operator is going to be basis to 0, basis to 0, dagger. And the other one is just identity because it gets ignored. And subspace of 1 can be done similarly by projecting the 1 state on the first qubit. My Emacs starts to lag. It's time to finish the stream. And let's make this controlled Hadamard. CH2, is this how I called it? Let me double check because I'm too drunk to remember. Yeah, I called it CH2. So in case of, oh yeah, and also let's make an identity. Identity of the dimensions of a 2-qubit system, 2 levels. Okay, so in the subspace of the first one being heads is just identity. And if this in the subspace of first one being tails, it's Hadamard 2. I think that should do. I think that should do the trick. So yes, I think that's correct. I think this is correct. Is it correct? Just think for a while. Yeah, I'm convinced it's correct. Okay. By the way, thanks Kaishwan for reviewing this logic. Oh, HH is not defined, it should be II. So stupid. So yesterday I showed it to Kaishwan, you know, if it makes sense, and he said it does. But actually I did find one bug in the notes. So Kaishwan, if you're watching it, I will explain to you on Monday what was wrong. By the way, do you guys think Bill Murray is watching us? Bill Murray, if you're watching this now or in the future, we think you're awesome. Yes, we have the result. So, yeah. So half of the times we just got 0-0 because after the first coin toss, it landed heads, and then we don't throw another one. And the rest is distributed between heads, tails heads, and tails tails, because when it landed tails, we threw the other one, so it sort of distributed the probability between the two. So yeah, that works. That looks fine. And the last challenge for today is finishing this glass. No, I'm kidding. 2 coins are placed heads on the table. We throw the first coin, and if it lands heads, we also throw the second coin. Program quantum simulation, blah, blah, blah. Okay, so that's basically the same, but now instead of we throw the other one if the first one is heads, not tails. So we will need to change our control operator, so let's call it CH0, whatever. And we will basically have to project this subspace differently. So in the subspace of 0, now we do H2, because that's the subspace of heads. And in the subspace of heads, of tails, we do the identity. And that should do the trick, I guess. That looks fine. Looks fine to me, looks fine to me. Wait, did I call it CH0? No, I called it CH2. Stupid me. And the rest is fine. The rest is fine. Okay, let's just run it. And as it runs, I will check the chat if there's any new messages. Hi, Bill Murray. Yes. Do you guys know when is Bill Murray's birthday? I think I will do a special stream on that day. Make it Santori time, yeah. Yeah, Santori time. Remember in Tokyo, we went to this bar and they gave us this sparkling water with whiskey. That was so good. Like, sometimes I go in CenturyLink Mall and there's Japanese restaurant there and it's on the poster and I just feel like I want to go there and have it. Good times, good times. Okay, so the subspace of, yeah, so 1-1, tails, tails, that's an impossible outcome because if the first one lands tails, we don't throw the other one, so the other one cannot be tails. So we never measured that, which is fine. Yeah, good times, good times. The pandemic just started then. Nobody expected what will happen still. We all thought that it will just be a few weeks or something. Then half of the times we got tails heads because we throw the first one. And for heads, tails, or heads, heads, it's evenly distributed because we throw the other one if the first one lands heads. So yeah, I'm satisfied. I'm satisfied, guys. Oh yeah, Moscow. Yeah, everyone was just messaging own girlfriends of or wives every few minutes just to show, like, yeah, we're being good boys here. Nothing happens. And when I pointed it out, you guys just laughed embarrassingly. Is Manny Kandan watching the stream? I am. It was quite funny when we shared the room. I mean, sometimes I was annoyed, but I kind of miss it. Okay, guys, I'm almost done with my beer, and we finished all the challenges. Let me just show you the circuits we just implemented. The ugly drawings on my iPad because I could not figure out the how to say the rendering thingy. It's okay. It's okay. Circs. Yeah. So first one is just trivial. 0, 0, nothing happens. So the way you read those circuits is like music sheet. You just go from left to right, which is opposite to the order of applying unitaries. It's like reverse Polish notation kind of thing, you know. Second one, we just flip the first one. Hold on, let me display the challenges at the same time. Yeah. So first one, nothing happens. Second one, we just flip the first coin from heads to tails. Third one, we toss the second coin, so that's the Hadamard gate. Fourth one, we toss the first coin, and if it lands heads, then we throw the second one. And the last one, the fifth one, we just throw the first one, and if it lands heads, then we throw the other one. So you can see the notation of the control qubit is a bit different. So we got it, guys. We got it. It's done. Still have some beer, so cheers. Let's plan next stream. What do you guys want to see? Episode 4. I propose to do quantum teleportation. I think that would be fun. It's something I particularly enjoy doing. Whoa, yeah, amazing, right? Quantum teleportation, because today, I mean, we know so far from episode 1, we know how to make states. From episode 2 and 2.5, we know how to make operators. And from episode 3, today, we know how to make circuits and do measurements. Yeah, they're entangled. They are entangled. Wow, all the results matching the experiments. All set, live, easy. Yep, we did it. Yeah, I think they are entangled because, yeah, the output of, I mean, how the second coin lands clearly depends on the outcome of the first coin, so they have to be entangled in a way. Although I'm not really an expert on entanglement, so if you guys are watching it in the future or are live right now, feel free to comment in the chat and say a few words about it. What do you think? What's your take on it? So yeah, do you guys want to finish? Like, we have been online for 58 minutes and I planned 20, so yeah, we are kind of overdue. So I will just show you this beautiful, beautiful thumbnail again. I just love it. It's so memic. And we're going to conclude right now. Thank you so much for watching. Thank you, Manish. Thank you, Tim. And thank you, Spambot, for being online and writing something in the chat. I'm really happy to have you guys here. I'm really happy to have a drink with you and do some coding for you. And for those of you who are watching it in the future, please consider to like and subscribe to my channel on YouTube or Twitch. It's really helpful to me. I really need, more crowd looking at those videos. Thank you. Cheers, Tim. And yeah, please stay tuned. Please look at my Instagram, LinkedIn, Twitter, YouTube, Facebook, whatever. And make sure you attend the next stream as well. Yeah, was fun. Thank you so much, guys, for watching, and take care. Cheers. Bye.